I don't know if it works right now. I guess it works. I don't know. Maybe I have to wait a moment. Right? This one is not the best thing. Oh, maybe I have to wait a moment. Right? This one is not the best thing. Oh, maybe I have to wait a moment. Oops, okay. I'm gonna start this channel. I mean, this commentary starting from uh, I don't know 1350 in 2 minutes. I'm gonna start this channel. I mean, this commentary starting from uh, I don't know 1350 in 2 minutes, and I need to check my voice and my screen. I'm ready to code right now here. So I have an editor ready, and I have this software already. So it's okay. Thanks for holding the discussion. So I can right now I can read the comment, but this is just because I'm looking at this channel from another channel from iPhone, so it doesn't work properly. Hmm. I still have 1 more minute. Uh, what? But I hope that I can update the status. So I don't know how many people are joining afterwards from right now, but there are currently only 4 people watching this channel. So I'm not sure I can start this one or not right now. But anyway, so I'm doing this commentary just because I cannot participate in AtCoder beginner contest as a contestant anymore because I'm currently part of the preparing team. So I can see the problem statement before the contest starts. So that's why I cannot participate in the contest. And actually, so I'm the writer of the problem A. So I know the problem statement before. So I guess it's a good time to start discussions. So let's start with the problem A. So in the problem A, you are given integer A and string S, I think. And if A is larger than or equals to 3200, then you have to add this one. Otherwise, you have to output red. So this one is based on the rating system on AtCoder. So if your rating is higher than or equals to 300, 3200, you can change the color into what you like. But anyway, so you have to read integer and string, and if this one is smaller than this value, then you have to output red. Otherwise, you can output what you wanna use. So for example, if the rating is this value and you wanna use pink, then you can use pink. Otherwise, you have to use red. So okay, I think it's correct. The next question. So you are given an integer sequence ai to an, and you have to calculate the inverse of the sum of the inverses of these numbers. This one. So in this problem, you can simply calculate the sum of these inverses, and after calculating the sum, you can calculate the inverse of this value by just simple calculation. So this one is also simple. So first of all, you have to current value. You have to store current value of these sums, and you have to read some integers and add 1.0 divided by c, and the answer is 1.0 divided by b. So this one is also simple. You just have to calculate stated in the program statement. I think it's correct. Yep. So the next question is this. I need to check the messages, comments. Okay, there is no comments. There are only 4 people watching. So the next question, you are given n items, and ith item is value avi, and you have to compose these ingredients n minus 1 times to make the best ingredient, and you have to make it maximum. And when you merge two different items, the value of the new item will be like the average of the two. So consider those cases. So let's consider. So this one is problem C. So for example, there are at first 4 items, and one of the possible ways to merge 3 and 4 and make it like this, and vi, v2, v3, v4. So in that case, the total value will be like a quarter of, the average. But you can consider the different shape of the tree, like merging 2 and 1 and 2, and merging this one and 3, and merging this one and 4. In that case, the total value will be like, this one should be 2, so a half of this one, because it was used only once for that merging. This one is a quarter of this value, and 1/8 of this one, and 1/8 for this one, because there are 3 merges, and you have to, the weight will be half and half and so on. So comparing these both cases, which one is better? So actually this one is better because you can modify as you like. So for example, you can sort and use allocate the largest value to this one because the constant is the largest, and the smallest value to this one because the constant is the smallest. So this one is the best way. This one is much better than just taking an average. So let's go. Also, the important thing is anyway, the total sum is 1. I mean, this constant. So it's much better to, differentiate between the two different values. So input, sort, and you have to calculate. So zero plus 1 divided by 2.0. Red point VT and VI divided by this value. This one is of course 138. So let's submit. So the next question, you're given a tree with n vertices, and this one is actually rooted tree, and so you are given edges, and you have to do Q operations, which is add xj, pj, and their children. Yep, it's correct. And after doing one, so after doing these all the operations, you have to output the value of each one. So actually, so some people might notice that this one is a good problem for writing ruler tree and doing segment tree, but it is kind of redundant. You don't have to do that. So assume the case where the graph is linear. This one is actually quite the same as some range sum problems. The easiest ones. So for example, so this one is the parent, and if you have to add all the values to range here, then you have to add the first one. So for example, you have to add 3 to each vertices between this one. You have to add this one. Then first of all, you can add 3 to just one vertex. And for example, if you wanna add 2 to this 5, then you have to add 2. And after that, so after doing all the things, then you have to take the sum, range sum of the first element is 0, 0 plus 2 equals to 2, 2 plus 3 equals to 5, and so this one is actually 0, and 5 plus 0 is 5, also 5, also 5, like this. Maybe this one is much easier to write. So this one can be applied to trees, rooted trees. So as I explained, all you have to do to process each query is that you have to add xi to certain vertex pi and another, for example, pj. So you have to add xj, and after processing all the queries, you can add the pressure sum from the top. Like so, for example, here is 0. Here is 0 plus x1 equals x1, and this one is x1. This one is also x1. This one is xj because and also maybe for example you have another query where you have to add xk. So in that case, this one is xj because this one is xj plus 0 and xj plus xk. So this one is xj plus xk, and this one is here is this one plus 0. So this one is also xj plus xk, and this one is also Okay, and after that you have just to output the answer. So it works. So let's code. So first of all, you have to input the graph. Oops, there are only a-1 edges. So this one is just inputting graph. And so I need to input another integer, which is the number of queries. So I need to process the queries next. And the value, maximum value is at most this value, so you don't have to use long integer VBlock. So you just have to add this value, and after that you have to calculate the answer by DFS as explained, like going from here to each vertex, and you have to add the current value which is given in the DFS function. So 0, -1. This one is to do DFS, and this means the current sum of the t to calculate the answer. So first of all, you have to calculate update ans a equals to c plus t. Then you have to go to each vertex. GA size, and you cannot go to the parent, and GAIA C plus TA, and after that you have to output all the values. I think it's correct. Yep, it works. Again, I need to check the comments. By the way, this KI pronounces ki, I think, and it means a tree in Japanese, but I don't know why they use Japanese name to that program name. Oh, damn, yours first. Wait, please explain how you made the tree in C. Problem C? So this one is actually merging two different materials. So in the problem's previous problem. So this problem is about merging two different elements into one. So after merging into this one, you can make one element, and so you can do the similar thing to merge and create one, maybe. So you can merge this one and this one into one, and this one and this one into one. So this process is like a tournament, like this. I mean, this is different from tournament graph, but yeah, like this. Merging two elements into one until there remains only one element is just look like a tree. And I just wanted to find the constants of each value in order to calculate the total sum. So in other words, how it is weighted for each element to compose the final value. And I just wanted to make it so biased, like for example, the constant, the constant is all the same, then you can make only average. Like if C constant is all the same, then you can make average. But this one is quite different, like this one like this. Then you can order each element from the smallest to the largest, V. So like V small v, larger V. And in that case, it's much more you can make because there are two larger values multiplied. So in that case, this one is much more, this one creates much higher value in the total at the end if you calculate Cy times Vi. And one of the best way to make this one, the most biased one, is to merge the smallest two values and merge this one and the third smallest values and merge this one and the fourth values and so on. I don't know which surfaces, but actually it is not more or less than this one explanation. By the way, I got a C on D. Okay, so let's go to the next problem. So this one I need to explain the problem statement. So you are given two strings S and T, and you have a lot of so S prime is just is continuing almost infinitely, and you have to find the subsequence of this one which equals to T. So you have to take some of the characters to make T. So actually, so this is a greedy approach problem because, for example, let's say S equals to A, B, C, B, A, and the first character of T is like T is starting with B. In that case, which B you have to take? Obviously, it is a better idea to take B in the left. So, and if you get C, you can take the fast C. Otherwise, if you take the right B, this one, you have to wait for the second round and use this one instead. So it's always better to take the leftmost characters after the character you have selected, and which equals to the current character you need in T. So what you have to do, what you have to prepare is for each position, so there are m plus 1 positions where n is the length of S. You can have where is the next character. For example, from here, the next character, C appears right next, so like here. B appears two characters from here. A appears at the three characters from here. And D doesn't appear, so you need to go to the end. For example, if you consider here, even B doesn't appear, so you need to go to the end and restart the newest character, newest S, from the beginning. So you need to store these characters, these arrays beforehand. And if you construct from the last characters one by one, then you can compose this one in order n times 26. So it works as it's just less of a million characters. So let's code. And of course, if a character appearing in T doesn't appear in S, it is always impossible to make the character, the string. So that's the important part. So first of all, you need to input these two. Oops. So first of all, I need to reset. This one is -1. Then, first of all, I need to update the value last. This one is, I need, this one is here. And you have to update this value. This is okay. And I guess the answer will be doesn't fit in int, but it doesn't matter. Assume that T is repetition of A and S contains just one A, although the length is really long. So in that case, so index is 0, the first character you are looking at. So in that case, if current index and the current character you wanna use is not -1, then you can move to that position. Otherwise, so I think that I need to use this one. Otherwise, you have to move to this, and you need to look at this. Otherwise, it's impossible to make. So in that case, I need to output -1 and finish the program. Otherwise, so this one should be index. And finally, I need to output the at times n plus int. Then -1, 33. Oh, it says that it doesn't fit in 32 bits. That's cool. There's no comment. So the last question, you are given two integers and you need to find the pairs x and y where the XOR of x and y is the same as the remainder of y divided by x. This one is really important, interesting problem. So I need to explain the solution. So the problem statement, f, you are given x and l and r, and you need to find a pair where y%x equals to y XOR x. And the first findings you need to find is this one is smaller than or equals to at most y minus x, because here states that y is larger or equals to x, so it doesn't happen where x is larger. So it's always false. And the next one, this one is at least y minus x, and the equal happens where y is the subset, x is the subset of y. So in that case it falls. Otherwise, for example, here is 0 and here is 1, then here should be 1. This one changes into 1. It doesn't hold true. In that case, it's just inequality. So, and this one should be equal. That means that we should, so this one should be equals to y minus x. This one is also y minus x. And so the important findings is that y should be smaller than 2 times x. And of course, x is a subset of y. If you consider as a set of bits, in that case, so x and y equals to x. This. But this one is, these two are the important thing. And let's consider y is starting from certain bits. And so this one is 0, 0, 0, and so on. In that case, so x should be right around here, that should be 0. And like, let's assume that this one is like this. And for example, if you assume, so if you think this one is 0, then it doesn't hold. Fourth doesn't hold. For example, so if you are focusing on this subset thing, you can create advanced this, and you can subtract, which you get this, and this one is still larger than these values. So in that case, y is larger than this value, so it doesn't hold good. So at least here should be 1, and the remaining part should be subset. So this one works. And also in that case, so for example, the highest bit of y and x is the same. In that case, it always holds. This one always holds. So you need to consider only these cases. X is subset of y. So what you have to do is some digit dp. So the first several bits should be 0. So both x and y is 0. And at the first time, you need to use both 1. And after that, if you set y, so here is y, here is x. So this one is 0, then you have to use 0 as well. If this one is 1, then you can choose from 1 or 0, any. And also there is a lower bound and the upper bound of these two values, which equals to, here. So what you have to do next is keep L is smaller than X, R is larger than Y. This can be done in some DP-like way. So the DP key is it starting yet? which corresponds, so if not starting means there is only 0 in the top bit, and L same, R same, which corresponds to where the top several bits of X is equals to L or not, top several bits of Y is equals to R or not, which is the important part in digit DB. So let's call code. So by far this is the hardest problems in this problem set, much harder than the previous problem. And yep, I got AC on E, so anyway I need to code, and so I have to find the solution. I need to find the answer modulo 1 billion plus 7. Okay. So in this problem, you need maybe 4, 61, 2, 2, 2. 60, 0, 0, 0. And after that, the only important part is here. So dp0 1 ij, and don't forget the Tika modulo and output. So I need to write this dp part. So first of all, if j equals 0 and you just want to skip, the only transition important is j is equals to 0 and you want to use 1 bit. So in that case, y minus 1, j is 1, and something. So k and l, k and l. So when is it possible? First of all, it is impossible to use if L equals to 1, 0, 0, and so if L equals to 1, then you can use. It means that R and Y doesn't have same bits at the moment. Otherwise, B times the current bit is 1, or there's no or, I think it's just all. Is this the old constraints? So this one is a requirement. Another requirement is k. Next requirement is k equals to 1 or 8. But in this case, it's always okay. Yep. And if A doesn't have current bits, but so you are using this one, then tk is going to be 1. And if it doesn't hold true. So tk tl 1 5 tk tl. This corresponds to using both 1. The next case is just using 1, 1 0, I think. So there is 1 0 or 1 cases. So otherwise, so the rest of the case is just skipping one value. The rest of the case, which corresponds to not using the integer at all, not adding the current value. This is true if k equals to 1 or it doesn't have current value. In that case, it's possible. And in that case, t equals 1, k tl, k tl. This one should be l, not tl. And if b has current bits, then it's gonna be okay because you are not going to use current value. Yep. And present mod. Otherwise, you have 3 choices: 1, 1, 1, 0, or 0, 0. So there are 3 choices. The first thing is both using 1 in that case. This one is in only matters. So I think the condition is the same. Okay. So in that case, you're using both 1 tkl. That's correct. So there are 3 patterns. The next one is both. If you are using 1 and 0, then you have to carry both. In that case, this one is 0, this one is 1. You can update it here. 1, 0. The next condition is using both 0, which corresponds to here. So you need TL and almost the same, but here. I guess it's correct. I don't know. It's kind of complex. Oh, it seems very good. Submit. Where is spaces? I don't know what you are talking about. Which space? Where is spaces? Oh, you mean my coding style? Oh, so I actually don't want to insert a lot of space because it doesn't fit in the leftmost part. I need to enlarge the window and maybe I'll need some additional screen. I mean the coding space. Do you actually mean coding space? You mean the space in the source code? If it is, I don't like to use a lot of spaces. It works anyway. Oh, okay, I got the correct answer on F. So, yeah, overall, it's a great problem set. Compared to the previous few ABCs, I don't think it's the hardest ones. So, if you're, yeah, that's correct. So, I'm gonna close this channel, and but I'm posting several videos, so if you're interested in these groups, why are AtCoder Grand Contest so much different to Sea of Clowns? I did the last, yeah, so it's really interesting question. So they're more like some mathematical puzzles, and it's maybe much more like mathematical Olympiads. So it's just because, so not even the first one, so it's just because that contests are not focusing on some. I once heard that it is not even focusing on intermediate level coders because there are a lot of other kind of contests. For example, if your rating is lower than 2000, if you are blue, then you can do participate in a beginner contest. Otherwise, even otherwise, you can participate in some AtCoder regular contest or some other contest. So obviously they are not focusing on some intermediate level coders. They're just holding a contest satisfying for red coders or some top levels like Kyoto or Tourist. And the problem is really like mathematical Olympiad, but I guess it's just because of the RNG's hobby, RNG's interest. He doesn't like data structure problems, so I don't think he would choose that data structure focusing problems for grand contest or maybe for the regular contest. So that's why code forces is more like focusing on data structure or problem with 100,000 to 100,000 constraints and takes a lot of implementation. But at Coder, especially grand contest, it's just a mathematical puzzle, so it doesn't require much implementation. But anyway, so I'm gonna close this channel. I mean, this broadcast. So if you're interested in other videos, please subscribe and wait for the upcoming videos. Thank you.